The next speaker is Samantha Quin. Samantha is a software engineer and amateur photographer from Brooklyn, New York. So it's a lot far away from here. She is currently an engineer and director at Skillshare, and prior to joining them, she led the payment engineering team at Etsy, was a principal software engineer at AOL, lead engineer at Politico, and worked on numerous projects over a decade at Visa. I also knew Samantha because she just finished her role as a core committee member on the PHP Fig for, I think, 2 years. So welcome, Samantha.
Thank you.
Hi.
Hi. Let me see if I can share my screen. Is that good?
Let's see. Yeah, I'm seeing that. So I think it's pretty early from you, right?
It's no, it's almost noon, so not too bad.
Okay, so we have found the sweet spot for you. So the stage is all yours.
All right, thank you. Hi, everyone from New York. I can't tell you how excited I was when the team invited me to come speak, and then the thing happened. First over there in Italy, and then here in New York and everywhere else, and it's been such a wild and unsettling year. So before I get started, I just want to say that while I'm so sorry we couldn't all be together today, I'm really grateful and inspired by the organizers who still managed to bring a sense of community and togetherness. So even though we can't all be in the same room together. I'm Samantha, by the way, if you don't know me. I'm an engineering director and a software engineer. I've been working in open source since the early 1990s. And the organizers asked me to come speak about how PHP has grown to be such a central technology for the web since its very first release, because this year, 2020, PHP turned 25 years old, which is just about the same age as my career. I've been working professionally for almost 24 years and working in open source since like 1992, 1993. So PHP and I have been together since the very beginning, at least of my career. It's really amazing to me to think that there are professionals across the world who are using PHP every day in their work, and they weren't even born yet in 1995 when Rasmus released the first version. That just kind of blows my mind, the kind of endurance that this language has had. And if you ever hear Rasmus speak, he always talks about how he always thought there was maybe 6 more months left for PHP, and here it is a quarter of a century later, and we're still talking about PHP and still building incredible things with it. I will also apologize before I really get started. If any cats or dogs or birds or children wander into the frame, I've done my best to make sure everybody's needs are taken care of, but things are the way that they are. So, if you've heard me talk before, you know I like to break topics down to their very basic components, and to talk about a high-level programming language like PHP, we have to talk a little bit about mathematics. So I promise it's not going to be too complex. I think everyone's going to be able to follow along. We'll start with this. As early children, we learn to approach mathematics through counting. We learn 1, 2, 3, 4, 5, so on. We learn that we can keep chaining plus ones to add up any number that we want to. We can even see with a much more complex addition problem that we can reduce this to a series of plus ones, right? So if we want to look at 2 plus 2 equals 4, well, 2 is plus 1 plus 1, and plus 1 plus 1, right, equals plus 1 plus 1 plus 1 plus 1, which is 4, right? Counting. And then we can go in reverse, right? Once we've mastered addition, we can learn that we can count backwards. We can take a subtraction problem and reduce it to a series of minus ones, rather, what is a minus 1? It's a plus negative 1, right? So 4 minus 2 is, as we already established, plus 1 plus 1 plus 1 plus 1 plus negative 1 plus negative 1, which gives us 2, right? Backwards counting. No matter how complex the arithmetic gets, we can always break it down to a series of increment operations, right? 4 times 2 equals 8. Well, we know what 4 is. It's a series of plus ones. And we know what we can then add that to itself, and we get an 8, right? Counting. Even division, which for me at least, when I was in elementary school and grade school, was the kind of the hardest arithmetic to learn. We're still talking about the product of incrementation, up and down the number line, right? Counting. We learn how to subtract, multiply, divide, raise, take roots, and so on, and different methods to solve those problems. But we learn those different methods because linear counting is extremely inefficient. We can't take the time to count millions of times to solve an addition problem. So we learn arithmetic techniques that are masking a lot of fancy counting. So why am I telling you this? Obviously, I'm not here to teach arithmetic. I'm going to assume everyone listening has mastered these basic topics. What I want you to remember is that all of the complexities of arithmetic exist to make computation easier for human brains, right? Our brains don't work linearly. We're actually quite limited when it comes to conceptualizing numbers. For example, most people can only remember a sequence of around 7 digits easily. So when we learn a phone number, we use things like mnemonic sequencing to help us, right? So in the United States, we have 11-digit phone numbers, right? Because the country is so large and we have the same country codes as Canada and Puerto Rico and Guam, American Samoa, and half of the Virgin Islands, we usually just drop the country code, which is 1 anyway. So we have 10. So we have an area code that generally corresponds to a state or province or part of a state or province, and then an exchange code, and then a station number, an extension number, right? So instead of trying to remember 212-555-1312, we remember 212-555-1312, which really works well for how our brains work, right? We can remember these very short little sequences of numbers and then sequence those sequences together and build up more complexity from there. In the 17th century, Blaise Pascal, who was the son of a tax official, started working on a machine that could use linear counting and carrying to perform computations mechanically. He went through many, many prototypes and received a royal patent in 1649. Over the following years, he built around 20 of these calculating machines, which are called Pascalines. There's, I think, 9 or 10 of them still kicking around the world, mostly in museums. Machines like this could really help with the tedious work of arithmetic for occupations like counting taxes. But there wasn't a ton of general use for a machine like this at that time. Over the centuries, lots of people, notably Gottfried Leibniz and Thomas de Colmar, repeatedly rediscovered this use of linear computing machines. And in the 19th century, Ada Lovelace was theorizing about how such machines, specifically theoretical machine, the analytical that was designed by Charles Babbage, how they could implement general purpose logical operations. So not even just doing arithmetic, but how you could use the relationship of numbers to encode logical operations, which is an idea that really wouldn't surface until Alan Turing's Turing machines, which happened just before, when really is the invention of computer science. The idea of a Turing machine, a machine that, given an amount of storage, can compute any number by encoding instructions and data together along a linear sequence of data. World War II created a resurgence of research into these mechanical computers. They really needed to meet a huge need of calculating ballistics tables. So it's a really interesting problem when you think about a gun that you're going to use in war, and you need to know precisely what angle that it needs to be at to hit a target a certain distance away. And to do this, they would pre-compute tables that would then be shipped along with the gun to the gun crew on the field who is using it in war, so they know how to use the gun and how to point it to hit the things that they want to hit. And this was a tremendous amount of labor that went into it, and you had rooms of human computers who were doing these computations manually. So the idea of having a machine that could produce these tables without this huge requirement of having mathematicians doing all of this trigonometry by hand really was spurred on by the war effort. Over the same time, we work on these practical sort of electromechanical logic gates had been continuing, and you have folks like Akira Nakashima and Claude Shannon doing a lot of pioneering work. when we see these areas of research come together in the 1930s and the 1940s, we start to see the viability of computation using digital logic gates, right? So as opposed to a linear mechanical accumulator, to build, where we can build general purpose computers out of these logic gates that are built out of digital circuits. So it's doing the same thing, but rather than turning wheels and gears, we're using electrical states to represent numbers in binary. The power here was that a computer like this could be reprogrammed, right? So you're not creating a machine out of gears and cogs that can't really be changed. You're creating something where the logic circuits can be rearranged into almost an infinite number of different sequences to produce any kind of computation that you want, right? So the first generation of these computers, like the ENIAC, had to be reprogrammed by literally rewiring the logic circuits. This is a photograph of Fran Bilas on the right and Betty Jean Jennings, who were two of the ENIAC's programmers. And you can see the plug boards that they use, those plug board panels, were actually used to program the computer. So if you wanted a new program to run, you move the plugs around to create new logic circuits. Interesting fact, Kay McNulty, who's not in this picture, was the person who figured out that you could use the instruction stepper to jump to other places in the code. And together with Betty Jean, they used this discovery to implement if-then logic, right? Which was not actually a feature of the ENIAC, and its hardware designers didn't consider it to even be possible with the hardware, which is interesting when you think about like how even in the 1940s, we're seeing programmers pushing their hardware beyond its original designs. And also, it's funny to think about the fact that a human being, and these particular human beings, Kay McNulty and Betty Jean Jennings, actually had to invent and discover things like if and go to. And these were not concepts that existed before they created them. So we quickly start to see machines that use static hardware that can execute a series of symbolic instructions. Instead of having to rewire the computer, you provide a different sequence of instructions and the computer does something completely different. So it was here in the early 1950s where we start to see these symbolic instructions evolve to be more approachable to human beings. So the first of these were machine codes, right? These were a specific series of bits that a specific piece of hardware was designed to execute. So each computer of a particular model would have its own set of instructions, and this would be shipped to the company who purchases that computer in a manual, and then the programmers would then use those machine instruction codes to program the computer. Programmers over time developed a sets of mnemonics for these instructions, and these were called assembly languages. So you write your instruction using these mnemonics, and then you pass those instructions into another piece of software called an assembler, which then translate it directly to the machine's own instruction language. So in this case, as long as you have two machines that are roughly similar, even if they don't have exactly the same sequence of bits to represent those instructions, you could potentially start to see programs that are portable across different pieces of hardware. So these mnemonics were very opaque still. If anyone has worked on an assembler, you know how hard it is to create a program that's significantly complex because it is verbose. You're dealing with individual instructions. Folks are working on ways to write programs in languages that were more representative of the way that humans talk and think. So in 1952, Alec Glennie, who was working at the University of Manchester in England, and Grace Hopper, who was working at Remington Rand, a company in the United States, they both developed separately practical compilers for the languages Autocode and A0, respectively. So these were languages that were human-like and very, I don't want to say primitive, but we wouldn't really recognize them as high-level languages today, but they were representing logic using commands, using statements, as opposed to using machine instructions. And then they had software compilers that would then take this logic and turn it into machine code. By 1954, John Backus's team at IBM was working on FORTRAN, which is the first language I think we can really recognize as a true high-level language. I would say most of the people that are watching this can probably look at this program and with a little bit of thinking figure out exactly what it's doing. It's just implementing FizzBuzz. It's pretty simple. This is one of the first, pretty much the first high-level computing language, and it's honestly still in use. It's still used in scientific computing. So, it's what, 70 years old, and it's still going strong, or 60 years old, and it's still going strong. We also see over the next couple of years more languages of this sort of same kind. Most notably COBOL, which was designed by a committee, an international committee, as a language for writing business programs, and the programming language Lisp, which was developed at MIT and was used for a lot of AI research. So FORTRAN heavily inspired a language called ALGOL in 1958, right? And this was this heavily inspired Christopher Strachey's team at the University of Cambridge to create a language called CPL in 1963. That inspired Martin Richards' team to refine CPL into a language called BCPL in 1967. 2 years later, a couple of engineers who were working at Bell Labs, Dennis Ritchie and Ken Thompson, took BCPL and also some ideas from languages like PL1 and created a language called B. When they decided they wanted to take B and extend it with a more robust type system, it only made sense to call it C. And C is a very important language for those of us who work on the web. I wanted to come to it in this way so that it's lineage from FORTRAN, it's direct lineage from FORTRAN, and the earlier symbolic and non-symbolic programming methods before it are really clear. C has continued to impact our modern world because it is the language of Unix, and therefore it is the language of Linux and GNU, and the heart of the entire world of open source. PHP's own interpreter is written in C, and is really reflective of C's standard library, right? P is very much one of C's descendants. I like to think of programming languages as like a family tree, right? You have these kind of three great founding languages: FORTRAN and COBOL and Lisp, and then they have all of their descendants. So if you look at that family tree, PHP is very much a descendant of C, much like C++ or Java. But despite that parentage, PHP really takes after a more distant relative. So let's take a step back and talk about great anti-COBOL. So before we start, okay, I know PHP is like COBOL, which is a sick burn. I love PHP and I love COBOL. Both of these languages get a ton of hate that they don't deserve. I mentioned before that COBOL was designed by a committee, and in a lot of ways it shows that. COBOL rewards programmers for being really verbose. It tries hard to be accessible to people who aren't computer scientists, and thus it tends to get in the way of programmers who are trying to use it. But COBOL is above all things a language that takes a pragmatic approach to its own development. And that's really what's caused it to endure. A good example is if you think about how you would write a program to divide an amount of money. Right? We know it's a bad idea to use floating points in languages like C or PHP because floating point math can be imprecise. Right? So we find ourselves doing what? We multiply out the decimal, right? So we multiply by 100, move the decimal to the right, treat the number like an integer. We do our math, and then we can move the decimal point back to where we know it belongs. We can round the numbers out consistently, right? I think we maybe do this so often that we don't think about how much work is going into accomplishing that simple task. COBOL took a different route with solving this problem. The committee knew that this language was going to be used to write business programs, so and maybe we could just have a binary coded fixed decimal native data type. Right, so literally taking a number data type, packing bits onto the end of a value to place a decimal. This is not what the hardware was designed to do. Most of the operating systems that COBOL runs on don't expect it. It's a hack, right? But it makes it easier and faster to write accurate business software in COBOL. It was a pragmatic choice that maybe wasn't the cleanest, but got good stuff done. if you remember when we used to leave our houses and go places, we would get into airplanes full of people and they're breathing and they're droplets, and we would fly to other cities and countries, sometimes even across oceans. And that system requires the coordination of almost 50,000 flights every day with each individual seat and cabin code and itinerary. And this has to connect to government databases. It connects to passport control. Individual airlines need to be able to communicate with each other about their routes and availability in real time. And these systems are largely written in COBOL. This code drives a sector that represents a little over 3.5% of the world's economy, almost $3 trillion a year. It's running on COBOL, right? So if you've ever booked a flight online or been rerouted around a weather event or rebooked on another airline when a connecting flight of yours was canceled, it's probably some COBOL code that made it happen. Or how about our global payment system, right? The last time I checked, just the Visa network alone, and I single them out because I worked at Visa and I wrote COBOL at Visa in the 1990s and the early 2000s. Just the Visa network alone processes about 500 million transactions each day. You can fly to Beijing. You can walk into a shop, buy a cup of tea, and in less than a second, that transaction goes from Beijing to Japan to England. It goes to the bank in your home country, then all the way back along that path. Less than a day later, your account is updated with the charge in euros or whatever your whatever the local currency for your bank is, and the tea shop's account gets updated in yuan. And this happens 1 billion times a day as prices change, shops open and close, currencies change their value relative to one another on a minute-to-minute basis, and it all works. If you pay for things with anything but cash, likely there's some COBOL making that happen. So when I say that PHP is like COBOL, I don't mean in the way that they have flaws and quirks that make computer scientists feel queasy. I think that's true of every computer language, and it's certainly true for PHP and COBOL. No one's going to argue that they don't have weird quirks. The point is that languages reflect the imperfections of the use cases that inspire their design. This is why we call them general purpose languages and not universal languages. I wouldn't use PHP to write code that requires real-time management of threads across multiple CPUs. I could, there's nothing stopping me, but there are other languages that are better suited to that task. And PHP is better than most other languages where it excels, which is programming for the web. I say this a lot, and people look at me because I do work in a lot of different languages and a lot of different stacks. If I were going to start a project to have a web-fronted application, an API, my choice is still PHP 25 years later. So when I say PHP is like COBOL, I mean they're both languages that people have been calling dead for decades. But they're both languages that continue to be used every day in millions of applications. They're languages that solve problems and that help people move and communicate and interact. So we're almost to the present day. Let's talk about the internet in the mid-1990s. The first web server was stood up by Tim Berners-Lee in 1990. This is it. And it really revolutionized the internet. People with internet access, who were at the time mostly university students and faculty, but increasingly people who were using commercial internet service providers, started making simple home pages to reflect their identity or their work, their research, their hobbies. So if you wanted to create a web page in 1995, it was pretty straightforward. You wrote some HTML in VI, and I do mean VI, not Vim, thank you. You FTP'd a few images to your server, and voila, you have a presence on the web. The complication comes along when you want something more than just a static page, when you want some kind of sick interactive functionality, right? Maybe you even want to allow users to generate content or have another kind of meaningful interactive experience with your content. You need to write actual business logic, but where do you put it, right? So you could potentially write your own web server with all of your custom logic built in. And that sounds silly, but that's kind of how Node.js works, right? Usually you use something like Express or at least the built-in HTTP module, but you don't have to, right? Everything is contained inside of this one application. And that was less accessible in the 1990s, although people did write custom web servers in C and then Java. even things like Perl. But the more ideally, you want to be able to use a real web server, something like Apache, and have it run your code for you. So in 1993, there was a team of researchers at the National Center for Supercomputing Applications in the US, which at the time was pretty much like the heart of internet research in the United States. It was led by Rob McCool, which is the coolest name I've ever heard in my life. And they presented an open standard for web servers to execute external programs. This gateway interface specifies what inputs the web server needs to supply when executing a program on behalf of the user. And then that program would return HTML. That web server can just serve it as if it were a static HTML stored in a file, right? So if you were a programmer in 1993 and you wanted to create a dynamic web page, you were at least a little comfortable writing C, and it was pretty straightforward. It was ugly. I mean, you're literally writing HTML in your C code, which is gross. But it worked. And if you didn't feel comfortable writing C, you could use any language you wanted as long as it had some gateway interface. So Perl had the GW module, and you could use Perl, which if you were a system admin at the time, rather than a programmer, you were probably much more used to working with. And it's the same basic concept. You get a request in, there's some variables that get passed into your program, and then you just print out HTML and it works. This was an ugly and sometimes difficult to use system. And there was a fellow who was kind of working on web systems at the time. His name was Rasmus. It was Rasmus. And he came along and he started building out a set of tools to create a bridge between writing CGI directly in C and writing HTML. It's funny when you think PHP has this terrible reputation of you just mash all of your logic and your HTML together into one thing. Really, when PHP started, it was Rasmus's attempting to break those two concerns apart, to break apart the logic and presentation layers into different places. So in 1995, he released version 1 of the personal homepage tools, the PHP tools, which he described as a set of small, tight CGI binaries written in C. And they performed a few very simple functions like logging, or the ability to receive data from forms and talk to a database. He was, as he puts it, trying to create the C API for the web, right? If you look at it the way that this kind of very early version looked, it's very much just an API for the web, where you have some very simple ability to set and receive template variables, do a little bit of comparison logic, connect to a database, things like MSQL and eventually MySQL, SQLite, and all these others, Oracle, in a way that allowed you to essentially write a template without having to think about the underlying code. And to implement this, all you would have to do is write a very small CGI binary in C, and there you go. You have your function exposed directly into your HTML, which is really very powerful. The reason that PHP was so interesting and powerful at the time is because instead of approaching this problem from the perspective of writing code, so you want to have some dynamic stuff happen on your web page, so you're going to sit down and write some C, or you're going to write some Python, or you're going to write some Perl. PHP came from the idea of gluing together the 4 concerns that you need to provide dynamic web content. It's much more focused on the actual problems. You have an operating system, you have a web server, you have some kind of business logic and a data store. And how are you going to combine these 4 tiers together to provide a good experience for your user, right? The CGI model, like I said, was pretty straightforward. You receive a request. So let's say we're talking about Apache. Apache receives a request. It looks up where to route that script. So it has a path that comes in, the request path, which is then dynamically routed to a script. If you've worked with htaccess or HTTP config files, you've looked at kind of how this routing works. Apache then runs that program. We capture the output that comes from the programs. Remember, we go back, it's outputting HTML directly. So we capture that output and we return the output to the client. It's a very, very straightforward way of running applications. it wasn't the fastest thing. So if you think about kind of the two leading ways to write dynamic web pages at the time, you have C, which loads super, super fast, right? But it's C, so you're dealing with memory management. And then in the 1990s, memory management in C was not as advanced as it eventually became. So even though, once you have a compiled CGI binary, it loads lightning fast. Apache calls it and it, boom, runs. There was a barrier to entry and the potential to, to have more crashes. Or you could use something like Perl, which was much more approachable than C for most people, but was very slow. By the time you actually, like, the Perl interpreter starts executing the program, Perl itself was very, very fast, but the overhead needed to start the binary, start the Perl interpreter up and run the program was very, very high. And then you had PHP come along, which was extremely slow compared to Perl. And obviously compared to C, and also was still kind of C. You had to write C to create functions for it. So it was kind of the worst of both worlds. But why did it not die at this point? Well, there was something about it that was really, really attractive. And that attraction really came to the forefront when we see mod PHP. So early on, Rasmus was really pushing hard to pull PHP into Apache, and for two big reasons: speed and safety. So if the PHP interpreter is pulled into Apache, we don't have this long time frame waiting for the interpreter to start up. So with mod PHP, by the time, even though still the Perl interpreter was much faster than PHP, by the time the Perl interpreter started, ran the program, returned the output, and shut down, your mod PHP script was done. It already ran. And that also brings a bit of safety. So, even to this day, PHP doesn't crash very much, but if a PHP thread in mod PHP crashes, Apache just starts a new one. It's not a big deal. You're not going to end up bringing down, if you have like a multi-threaded concurrent single server, potentially one thread could bring down the whole application. That's why you see things like Node.js being really, really popular, because it's single threaded and it uses an event loop, right? Or React PHP. It's single threaded and uses an event loop, so you don't have this trouble of trying to coordinate multiple threads, potentially losing a thread, having it crash and corrupt memory and bring a bunch of stuff down, right? So single threads are safer and much easier to work with. The real killer for PHP that made it take off like lightning was hosting, particularly shared hosting, right? So early on, and even still today, it was very, very common to host your web page on a shared host. So you would be on a virtual host using Apache virtual hosts, potentially with hundreds or even thousands of other accounts, right? So it doesn't really work well with C. You have to provide compilers. There's no thread safety. There's no memory safety. It's very, very fast, but you have that. You have a lot of issues that come with trying to run just random C programs written by who knows who on your server. And with Perl, you do have some more memory safety. It's an interpreted language with a good garbage collector, but originally Perl didn't have an Apache module, and when it did, they hooked into everything. So potentially Perl could steal requests from other virtual hosts in Apache. It was not secure in the sense of it wasn't secure for the virtual hosting environment, and because of that, it meant that if an ISP wanted to provide Perl, they couldn't provide it on that same virtual host. They couldn't host 100 or 1,000 accounts on a single machine. It had to be segregated off by itself. PHP, on the other hand, worked really, really well with shared hosts, right? It hooks into Apache very minimally. You have the thread safety, right? Because everything it's completely shared. Nothing. There's no threading. There's safety features that are built in that are weird and that people used to make fun of PHP for, things like the max execution time limit, right? So you think, why does that exist? Well, it exists because for a shared host, that even if somebody just goes in there and codes an infinite loop, whether it's a mistake or even they go and type while true, right? The PHP interpreter will eventually kill that no matter what. Same thing with memory limit. PHP could have a memory leak. An application written in PHP could have a memory leak, but there's a top level limit after which your application is going to get shut down. And this gave the owners of these shared hosting systems a lot more security and a lot more confidence that they could host multiple different applications in PHP on a single server without having to worry about them stomping all over one another. PHP got a really bad rap for this and for a lot of different reasons. And PHP has a lot of interesting quirks. And over the years, over the last 25 years, we've seen PHP really develop in ways that make it look and act a lot more like other languages. It's taken a lot of inspiration from Java. It's taken inspiration from JavaScript, which has also gone through a very similar evolution over the years. And there's still this idea that, computer science people think PHP is bad. And if you use it, you should feel bad. But I don't want you to feel bad. PHP, first of all, is not as bad as they say it is. And all of its badness is really what contributes to it being such a powerful tool for building on the web. In good languages, variables are consistent, right? Global variables are consistent. In PHP, you have to explicitly call a global variable. You have to make it explicitly call a variable global, and you have to, or you can put it into the globals array, which is ugly and dumb, and yet it's brilliant and powerful. In PHP, until recently, there was no way to clobber a variable in global scope unless you knew you were going to do it. You were either referencing something in this $globals array, or you were explicitly declaring in a function that this is a global variable that you're talking about. So while there isn't some consistency in this idea of having this global keyword where you have to explicitly set a variable as global as opposed to just understanding how scope works, well, I mean, you do need to understand how scope works, but if you're writing PHP and maybe you're not a programmer, maybe you're just trying to figure out how to do something in PHP, you're looking at the manual, you're looking through tutorials, and you're just trying to teach yourself how to do one specific task with PHP to make your web page do something cool. Knowing how variable scoping works is probably not something that you're comfortable with, and you're less likely to shoot yourself in the foot if you have to declare your globals explicitly. The good languages don't, in global variables in good languages don't get set or clobbered by magic. And in PHP, we have register globals. Register globals is one of those things that I think PHP got made fun of more for than almost anything else over the years. And, again, this goes to that person who is coming to PHP not as a person with a computer science degree, but as a person who has a web page and they want to have a guest book or they want to let people book appointments. Register globals was really PHP's killer function that made it accessible to people who weren't programmers. And you also have to remember at the time, there was no, JavaScript wasn't really a thing. Cross-site scripting wasn't really a thing. And this idea that you could write a form in HTML and you can, you have, the name and the email address, right? And that's what you call them in HTML. And then those variables just exist in PHP with those names. It was really very, very powerful for people who didn't know to think about all of this process of, well, when we run the binary, these register variables get set, request variables get set in the PHP interpreter, and then those are exposed internally as the $server or $register variables, and then you can read those from the $post, and then you can manipulate them. This is a lot of overhead for someone who's just trying to make something very simple happen. And when they create a form that has a field called name, it's $name. Right? It's a very powerful feature for people who aren't coming to PHP as programmers. Even something like magic quotes, which I to be fair, there's no excuse for magic quotes. They aren't good. They were a very bad solution to a problem, but they did provide a solution to a problem that people who didn't really understand the idea of SQL injection or even why it would be a thing that they had to worry about. It was a very easy way for them to not have to worry about whether or not they were properly escaping all of their HTML. Now, today in 2020, we would never consider using something like this. But this is 1995, and web development wasn't something that was professionalized. There were people who were building complex systems on the web, but largely these were tools that were being used by folks at companies and universities who were just trying to accomplish specific tasks. And they might be system admins, they might be quote unquote webmasters. Often they weren't people who had traditional programming backgrounds. We know that good languages have a consistent type system, and PHP also has a consistent type system. People make fun of PHP all the time. So if we look at PHP, look at the way it handles booleans. 0 is false and a 1 is true, but the string PHP is true, but an empty string is false, right? I mean, this is all internally consistent if you understand how PHP handles type coercion, right? I won't get into the details of it, but an empty string is type coerced to a 0 because any string that has a number in it is coerced into a numeric value. But if you look at something like C, right, which you can talk about type safety, C is the gold standard. What's the difference between a uint 16t and an unsigned short integer, right? Are these both the same thing? Well, maybe, depending on the operating system and the hardware that you're running on. It could be, it might not be, right? So to say that PHP's type system is inconsistent is to ignore that every language's type system is inconsistent if you don't know what it's attempting to do. I mean, in this case, an unsigned short integer is something that is very much platform dependent, while something like uint16t is not platform. It's always going to be that 16-bit unsigned integer. In PHP, you have to understand that type conversions happen, right? But they always happen consistently. There's definitely a table that you can look at and see how these conversions happen, and generally they make sense. In good languages, we use consistent case, right? And PHP functions aren't case sensitive. Well, that's fair. The consistency here really comes back to the time that this language was originally created. And back in the 1990s, there was a huge religious war over whether or not HTML should be written in all caps or in lowercase. And eventually lowercase 1, but at the time it was very much in the air. And Rasmus very intentionally wanted PHP to be usable no matter what your style looked like. So you had people who were doing lowercase and people who were doing uppercase, and you had people who were doing just normal English case, so the capitalizing the first letter and then lowercase the rest of them. He wanted PHP to work with any of those types of styles. And this was really one of the first big decisions that had to happen, where the consideration of backwards compatibility came into play. Eventually, like I said, lowercase won out, but going back and changing case sensitivity for function names would have broken lots and lots of web pages, which is something that Rasmus and the other folks working on the language at the time decided explicitly they didn't want to do. They wanted PHP to continue just working. And that is a decision that's been repeated many, many times over the years, and can be very frustrating for those of us who are eager to see the language continue to evolve and become stronger, but also has really cemented PHP as a language that people can rely on to get things done on the web. Let's see, the good languages have naming practices and conventions that are consistently applied. Well, PHP's naming naming is very consistent, actually, if you think about it. PHP is a set of underlying libraries, and especially when you're looking at the very low level, like original sort of PHP library, standard library. So stirpause in PHP is just sitting on top of the C library implementation, and all of the string functions are haystack needle. The array functions are needle haystack. They're consistent in these specific areas of concern. So string functions are a certain way because they're building on top of C's string manipulation library, and array functions are consistent because they're building on top of C's array manipulation. And it's the same for MySQL or for Oracle. These are all built on top of the underlying libraries and essentially just expose those libraries into the PHP runtime, right? So don't let anyone tell you that PHP naming is inconsistent and function signatures are inconsistent. They're extremely consistent with what they are. PHP was not originally designed to be a high-level reinterpretation of working on the web. It was the C API for the web. So who is PHP even for? PHP is for people who want to use the web to express something about themselves. They want to share things that they're creating, share their passions, share their hobbies. It's for people who need to build communities, right? It's for, think about WordPress, for people who are trying to share their hearts and their passions. Things like PHP these early PHP applications that, despite all of their problems, really created a sense of community on the web. In the late 1990s and the early 2000s, people were using PHP to create these, for their time, amazing tools that brought people together and let them communicate and form real friendship and communities with each other. It was for businesses, right? And not for huge businesses, which, don't get me wrong, huge businesses use PHP. Some of the biggest, Etsy that I worked for is a huge business and uses PHP. A PHP monolith, honestly, running under Apache. It's kind of old school PHP in a lot of ways. But more for small businesses. I have a coffee shop and I want to be able to have a presence on the web, and I want people to be able to interact with my business. And I can do that in PHP with the knowledge that there's a shared host that can run my site, that there are hundreds of thousands of professional web developers who know PHP or know WordPress or know Drupal, which are built on top of PHP, and can put this together for me in a way that doesn't require me to have a programmer on staff. It's an ecosystem that enables people to create in ways that they couldn't if we didn't have this conceptual bridge layer between being a programmer and not being a programmer. It's also for porn, and it's also for WordPress. These things have, it's funny, but they've very much been taken up by these areas that drive a lot of internet development. Porn is on the bleeding edge a lot of times of technology, and you see a lot of PHP used in that industry for that very reason, because you have folks that are coming at it from a perspective of trying to complete a task, and they're not always coming at it from the perspective of trying to perform some great feat of computer science. What is remarkable to me about PHP, after all of these years of using it, and I've been using it pretty heavily since about 2005, so it wasn't back in the PHP 3 days, but definitely around the time of PHP 4 to PHP 5, is that it is built to be programmer adjacent, right? It is meant to sit next to programmers, and obviously programmers build PHP, and people who are building systems, complex systems in PHP, are absolutely computer scientists and programmers every day. But it creates this connection between the almost inaccessible world of computers, a world that really doesn't make a lot of sense, and it's very, I don't know, for a lot of people, most of my friends are also in the industry, and it's very easy for us when we're all together to forget how mysterious computers are to people who don't work in this industry with us. When I talk to folks who aren't programmers, they have no idea how any of this stuff works on any level, really. And they might have some vague understanding of servers and data being sent across the internet, but the actual meat and potatoes of how it all works and fits together is a huge black box. And PHP provides a simple enough interface on the top of that mysterious box that you can come to it without fear and accomplish something. And that was what it was designed for, certainly. And the modern language has become, again, much more complex. But to this day, you can still come to PHP with a simple tutorial and look at the manual, and you can accomplish something. And I think that really speaks to the longevity of this original idea of creating a simpler way to create meaningful experiences and interaction on the web. PHP was not a programming language. it was a set of wrappers over standard C libraries that continue to get more and more complex over time. But it has become a programming language, and I kind of want to finish by talking about how far it's come. I mean, we think back to 1995 and that original Usenet post and PHP FI, the personal homepage tool / form interpreter, right? You could process forms, couldn't do math really. It was very much a templating language sitting on top of C. 1997, we have a new release, second release of PHP, where we can do things like loops, right? So we're starting to see this basic programming implementations, basic programming features coming into PHP. I still don't know if I would call it a language until PHP 3. Zev and Andy write a parser, right? They rewrote the PHP engine, and now it's really starting to look like a programming language, especially in then 2000. You see the Zend engine, another engine rewrite, a lot more power. You have primitive objects, this idea of primitive PHP4 classes where you can start structuring your code in ways that look a lot more like things like C++ and Java. 2002, the PHP command line came about, right? So now this opens up to running PHP not just on the back of a web server, but running an actual program, right? Writing a program and just running it like you would run a Perl or a Python program. 2004, another rewrite of the Zend engine. You have real objects in PHP 5. PHP 5 was a pretty monumental change. And for those of us who were in the community at the time, PHP 5 was an amazing change from a technological perspective. A lot of really amazing stuff came out in PHP 5. But really what impresses me about PHP 5 is the way that the community came together with the whole Go PHP 5 movement to really push everyone off of PHP 4. It was this monumental task because PHP has always concerned itself with just working. If you ever have a chance to look into into WordPress and why WordPress does all of the weird things that WordPress does, it very much follows that same philosophy of we want this to just work everywhere all the time. And getting people to move off of PHP 4 was a monumental task, and the community really approached it as a community and worked together to make it happen. In 2005, PHP 5.1 dropped with PDO, which was the first time we kind of start seeing PHP walk away from we're just going to create a thin wrapper over these underlying libraries, in this case, the database library, so MySQL, SQLite, MSQL, and Oracle, and all these things, and have a consistent API in PHP for interacting with those things. We eventually got native JSON support. Started seeing people start writing HTTP APIs. I won't call them REST APIs, but the idea that you could use PHP as something more than just like a templating language. You could use it to build the back end of complex systems that had to be distributed with, API servers and presentation logic being completely separated. You start seeing a lot more complexity come into the ecosystem. Then PHP 6 failed horribly, but we took all the good parts out of it and created PHP 5.3. We got namespaces. We got late static binding. We got closures. There was a rewrite of the garbage collector that made things much more memory efficient and performant. And we got GoTo came back, which is a very powerful, very powerful statement that PHP definitely needed. PHP 5.4, we got traits, which are, I think, one of the most underappreciated features in the language. The built-in PHP server, a lot of deprecations and deleting of ancient things from back in the day. 5.5, now we're starting to see things from, things that real grown-up languages have: generators, real exception handling, native op caching, the Zend optimizer. Lots of big improvements here. 5.6, start seeing variadics, constant scalar expressions, right? PHP now in 2014 is starting to look a lot like Java. PHP 7 came out with a real AST. They fixed bitwise operations, started seeing things like null coalescing, the ability to hint return types, scalar type hinting, a new rewrite of the engine, void types, which is the smallest thing that I could never understand why PHP didn't have. Big improvements in 7.2 for crypto. 7.3, pcre2 support. They fixed the weird here doc implementation that had been there for many, many years. 7.4 came out with type properties and arrow functions, array packing, the opcache preloading, which is huge, weak references, all these kind of engine improvements that make PHP run faster and more efficiently. The ability to have some limited variance and return signatures. These are things that make it a more practical, real language. And now, later this year, PHP 8 is going to come out, and I think Derek talked about it. I suggest you go bother him, but it's amazing what PHP. Think about PHP 8 versus PHP 4. It seems like maybe there's an interesting number relationship there, but there's not, because PHP 6 never happened. But it's amazing to think about what PHP is today compared to what it was 25 years ago. How this thing that was never meant to be a language eventually became not just a language, but a really powerful, approachable language that grows organically by looking at the best parts of other languages. PHP isn't afraid to look at Java, to look at JavaScript, to look at C, to look at all of these other languages and see what makes sense about them, and bring them into its own ecosystem. So PHP every year looks more and more like a Frankenstein's monster, and that makes it more and more beautiful as it continues to develop. So what about all of that other stuff? PHP at the end of the day is a tool. It's really a set of tools, and tools are important to us. We're the people who use them. We can look at them and we can appreciate them for their quality. We can appreciate them for their usefulness. We can appreciate them for their quirkiness, and how sometimes you need to know how to use a particular tool in just the right way to not hurt yourself. And it can be difficult. But the tools aren't what's important to everyone else. Those tools were the tools that were used to build the Hagia Sophia, and what matters, what the world remembers, is what was built, right? So what I want you to take away, what we look at as the builders, we're very close to, and we see all of the little flaws and the dirty things, right? We can look at something like WordPress, or look at something like Wikipedia, and see all of the weird things and the global variables and the intersection of imports that use raw directory paths and things like that. And it's very easy to see the flaws and the ugliness. But what the people we're building for, what they see is what's important. And we're able to use these tools, imperfect though they may be, to create amazing things that really enrich people's lives. Whether it's something like Wikipedia, or whether it's something like Etsy that provides this place for all of this kind of commerce between people. If it's something like Facebook, which is maybe great in not the sense of it being good, but impressive. We can do amazing things with these tools if we put our minds to it. So I want you to remember, the tools aren't what's important. The tools are important to us. What's important is that you go out every day and you build great things. Thank you so much for your time.
Okay, thank you, Samantha. There are a couple of quick questions from the chat. We'll try to answer them. So the first one is, why do you think that transition from PHP 4 to 5 didn't cause a schism in the community like it did, for example, for Python 2 and 3? As far as I know, there are comparable in terms of big changes. This is from Stefano.
That's a really great question. It's the community. So I was involved with Python through that same transition. The support was not there from the people in the ecosystem, the people who were developing the underlying libraries. PHP didn't so much have libraries in the same sense that Python had at that point, but there was this real push across the PHP ecosystem from the framework developers, from the folks working on WordPress, to just make it work, and to assure these folks who were coming, the people who were running the virtual hosting companies, the people who were running, who were, as a consultant, were building web pages for 20 or 30 clients in WordPress, that when we turned that switch from PHP 4 to PHP 5, everything was just going to work. Python didn't do that. The Python community created the 2 to 3 script, which kind of works when it works. And that's why I think you're seeing now, 15 years later, there's still people running, 2.7 out there. They really, they decided, we're just going to break backwards compatibility. This is the thing. We're just going to do it. We have to do what's right. We made some mistakes in the 2 family, and in 3 family, we're going to fix them. PHP did the same thing, but made the effort to say, well, almost all of your PHP 4 code is just going to work on the 5 interpreter. And that was really the difference. Both communities did the same thing, but PHP actually cared about making sure it still worked for all the people who were using it.
Yeah, that's a huge shout out for their internals of PHP. They always do a great job in that regard. And in fact, the next question is, do you think that migration from PHP 7 to 8 will take the same long time, like 5, 6 to 7 from Nicola?
Will it take the same time? I don't think it's going to be as bad. I think it's gotten better each time. I think we've been going through the 7.4 migration where I work, and it's been really, really smooth. Going 5 to 7 was fairly smooth. I think that a lot of the changes that we're seeing in 8, again, there's been a good effort made to make sure that 99% of PHP 7 code isn't going to break. So, maybe you're not going to be able to run stuff that was running on 5.6 and just expect everything to work. But, the PHP is very careful. The internals team is very, very careful and makes very, very deliberate decisions. It's both frustrating and heartening. You can always trust that the internals team is not going to leave people flailing in the wind. So I don't think it's going to be as big of I don't even think it's going to be on the same level as from 5 to 7. There's a lot less breaking, I think. And I think a lot of benefit to going to 8 that is going to be really attractive to people. And also the industry has really changed. Like, you're always going to have this lagging indicator of like the WordPress community. Not to dig on WordPress. I love WordPress. It's, I think, one of the most important and amazing technologies of the last half century. But you're always going to have this lagging indicator with like the like shared hosting WordPress world. But the way that we write software over the last 5 to 10 years has really changed, and we're building more and more small applications and doing a lot more composition of small applications into larger applications. So I think the burden of migration for most engineering teams is going to be a lot lower with 8 than 7 was.
Okay, great. Thank you, Samantha.
Yeah.
Oh, maybe we have one last minute question. I've always felt that extensibility of PHP via C, C++, and now FFI is another major perk. Do you feel the same way? From Michael.
Yeah, absolutely. FFI, FFI really made me happy because it was the most PHP thing that had happened to the PHP ecosystem in years. Yeah, some of the first stuff that I did with PHP was writing extensions. I actually wrote a PHP extension, a proprietary PHP extension at Visa that calculated Easter. And being able to do that kind of stuff and just like create your own modifications to the language is something that was really, you didn't see, like, you weren't going to go and write that for Python. You would be working in user space, and maybe someone would create a patch and do that. But in PHP, the ability to write those proprietary things, to have that, have the Zend API just like so available to you as an end user is really, really amazing. Being able to use something like FFI to just pull in arbitrary libraries, and I know there are people doing cool stuff with computer vision and things like that, where last time I worked in computer vision, you kind of feel hamstrung to the languages that have strong implementations of it. Now you can just expose those libraries wherever you want. I think that's really, really amazing.
Yeah, that's right. Okay, I think that we're done with questions.